Hello, today we are going to discuss how to replace your PI controller with a fuzzy logic controller. For this, we are using a chopper fed DC motor drive here, the simulating diagram of which is right in front of you. So there are two controllers. One is a speed controller and another one is a current controller. Speed controller is a PI controller, whereas current controller is a hysteresis current controller. So this is our DC machine from which we will get the actual current and the speed. The speed is taken to the speed controller. We will compare the actual speed with the reference speed of 120, and it is passed through a PI controller, the output of which will be IREF. IREF will be then compared with the actual current coming from the DC machine and will be passed through a hysteresis current controller, output of which will be fed to the GTO to control the circuit. So we want to replace the speed controller, the PI controller, with a fuzzy logic controller. So for that, we have to build a fuzzy logic controller, which I have already done. Okay, so we have two inputs here, speed and the reference speed. We are replacing this PI controller with a fuzzy logic controller. So the inputs are the actual speed and the reference speed. So we have the actual speed and the reference speed. The output will be the IREF. So the output of the fuzzy logic controller will be the reference current. Okay, so the main point is how to set the values, the range of values for our membership function. Okay, so setting the values of membership function only comes with experience and knowing the circuit more. If you don't know the circuit more, it's okay. You can keep a lot of scopes in the circuit and see how the circuit actually works. Okay, so we will check how the circuit works with a PI controller. So this is how the output looks like with a PI controller. The output, this is speed. First graph is speed. Second one is the current, actual current, and the third one is VA, this is voltage. So we have to take note of the ranges. The speed will vary from 0 to 135. So I have noted down some of the ranges. The speed should range from 0 to 135. Reference speed is always 120 because it's a constant block. IREF and IA should always should be same. Not always, but should be same. That's what our aim is, because if they both are same, then the difference will be 0. That is what we want. We don't want our IA to deviate from the reference value, and the reference value should remain as close as possible and overlap in ideal case, so the difference between them becomes 0. So this is how the graph looks. So we have the range of IA 0 to 2. We have also 0 to 2 is what I get, I guess. So we also have to take care that the limit of the current should not exceed from this, otherwise it's useless. You have to keep it in this range or less than this if possible. You don't want to overshoot it beyond 30. Okay, so that we are talking about the IREF, but IREF and IA are almost similar because that's our aim, to keep them overlapping as much as possible. Okay, so we have the speed, reference speed, as well as the output IREF. So we will check one by one. So this is the speed. The range is 0 to 145. As I told you, speed 0 to 135, but you can keep it somewhere close to that, because if that comes, you have to control it as well if it goes beyond 135. So we are keeping 0 to 145 here. Okay, we will design low, medium, high respectively. Then we will have the reference, the input of reference speed, which will have the value of 120 in our case. Okay, because we are using constant block of 120. So we don't care about low and medium. We are only focused on the high, which will be the range will be 0 to 120. Only thing you have to take care here is that at 120 it should have a high value. So we are using these graphs. Okay, so then the output. Now we know that the IREF and I should always be kind of very close to each other. So if we see the range of I, it is 0 to, it's somewhere around 2 to 30. So that's the reason why we're keeping it 2 to 30. Okay, so we will set basic rules here. So these are the 3 rules I have set. So this can also be, you can see the graphs and analyze it. Well, if the speed is low and the reference is high, that is, the speed is low and the reference is 120, always what should be the output? So you can see if the speed is low, this is the speed. If it is low, I is output, that is IREF, should be high. I should be high. So that is why we are ending up with this formula, that is, if speed is low and the reference is high, then the IREF is high. Okay, then we have, for what if the speed is high? We know this, if the speed is high, what is happening? If the speed is high, suddenly the current is going low. Okay, so that is why the second rule stands like, if the speed is high and the reference is 120 or high, then the IREF is low. And the third rule is for medium. If somewhere around 60 to 80, what is happening? It still remains high. Okay, it still remains the same. So that is why we are coming up with the third rule, that is, if the speed is medium and the reference is high or 120, then the IREF is high. Okay, that is how we design the rules for it. Now what we will do is we want to call it to we have to export this to workspace. Okay, now we will build a circuit replacing the PI controller, which I have already made. This is the fuzzy logic controller, and we have replaced the PI controller with a fuzzy logic controller. We will call it from the workspace, so we will type in fuzzy as it was there. So there you go. Oh no, yeah, there you go, fuzzy, then apply and okay. So now we will check the output. So you can say it's rising. Initially I told you I should be between 2 to 30. It is well below 30, so it's okay, like it should not go beyond 30. Okay, so the current is going right, it's going well. After some value, it's going down. That is, it starts from here, the high speed value. It should settle at 120, I guess, and it is going right to 120. Perfect. I think it's perfect. All right, you can see that's how it is done. The value of the speed is having no overshoot, and it is settled right at 120. So that is fine. Current is well beyond our set limit, that is, it's not going beyond 30 and it's not going below 2 as well. So that is fine, and we don't care about voltage at the moment. So this will stay the same for entire period of time. I'm not wasting your time. Thank you so much.